Welcome to AI News Digest 2026-0607. Today's 8 stories. Story 1, the latest AI news we announced in May 2026. Story 2, LLM News Today, June 2026. AI model releases. Story 3, AI applications news. Harvey ships contract intelligence. NVIDIA validates NVFP4 pretraining on 12B Mamba-Transformer. Story 4, Anthropic's push for interpretable AI could redefine how we understand large language models. Story 5, Google AI Edge Eloquent, free on-device dictation app for Mac. Story 6, browse Ollama's library of models. Story 7, Meta Llama 3.2 vision, multimodal LLMs in 11B and 90B sizes. Story 8, hybridizing large language models and Markov processes for autonomous penetration testing. Story 1, the latest AI news we announced in May 2026. Meta has made a significant move in the open-weight AI space with the release of Llama 4, its latest generation of large language models now prominently featured on Hugging Face. What makes this release stand out is not just the scale. We're talking about models with 109 billion and 402 billion parameters, but the fact that all of these models are multimodal, meaning they can process both images and text together. This is a major architectural leap from earlier Llama generations that were text-only. The adoption numbers are striking. The 109 billion parameter Llama 4 model has already been downloaded 452,000 times as of late May 2025, just weeks after its update. The larger 402 billion parameter variant has seen over 112,000 downloads in the same window. These aren't trivial figures. They reflect a massive and growing community of developers, researchers, and enterprises who are actively building with these models rather than just experimenting. Why does this matter? Until very recently, models at the 400 billion parameter scale were considered too powerful and too strategically valuable to release openly. Proprietary labs like OpenAI and Google have kept their largest models behind API walls. Meta's decision to release at this scale as open weights fundamentally changes the competitive dynamics of the AI industry. It means that any organization with sufficient compute can now deploy frontier-grade multimodal AI without depending on a cloud API provider. The rapid update cadence is also worth noting. Meta pushed multiple significant updates between April and May 2025, signaling aggressive iteration. This pace suggests Meta is responding to both internal benchmarking results and competitive pressure in real time. The broader implication is that open-weight multimodal AI is becoming infrastructure. Just as Linux became the backbone of enterprise computing, models like Llama 4 may become the backbone of enterprise AI deployment, widely used, freely modified, and deeply embedded in production systems. For anyone tracking the AI landscape, Meta's Llama 4 release is a clear signal that the era of frontier open-weight AI has truly arrived. Story 2, LLM News Today, June 2026. AI model releases. Cybersecurity is facing a fundamental scaling problem. Penetration testing, the practice of ethically attacking systems to find vulnerabilities before malicious actors do, is expensive, time-consuming, and dependent on scarce human expertise. A new academic paper from Lviv Polytechnic National University proposes an ambitious solution: a hybrid artificial intelligence framework that combines large language models with Markov decision processes and reinforcement learning to automate the entire penetration testing workflow. Here is the core idea. Large language models are very good at high-level reasoning. They can read about a target system, synthesize information about known vulnerabilities, and generate plausible attack strategies. But they are not well suited to the sequential, step-by-step decision-making required to actually execute an attack under real-world conditions where information is incomplete and the environment responds dynamically to your actions. That is where Markov decision processes come in. Specifically, the framework uses partially observable Markov decision processes, or POMDPs, which are designed precisely for situations where an agent cannot see the full state of the system it is operating in. A condition that is nearly universal in real penetration testing scenarios. A reinforcement learning layer ties it all together. As the system attempts actions and observes results, it feeds outcomes back to update both the tactical execution model and the LLM's strategic planning. Over time, this feedback loop should allow the system to become more effective at navigating novel network environments. The researchers argue this architecture dramatically improves automation, adaptability, and scalability compared to existing tools. And they are probably right in theory. The hierarchical design, LLM for strategy, POMDP for execution, RL for learning, mirrors how expert human pen testers actually operate. But here is the critical caveat. This paper is entirely conceptual. There is no empirical validation, no implementation, no benchmark results. The framework is a blueprint, not a working system. Real enterprise networks have state spaces that would make POMDP computation intractable without significant approximations. LLM hallucinations could generate attack paths that are logically flawed or easily detected. Despite these limitations, the paper represents meaningful theoretical groundwork in a fast-moving field. And it raises an important dual-use question. The same capabilities designed to help defenders could, in the wrong hands, power autonomous offensive cyberattacks. Story 3, AI Applications News. Harvey ships contract intelligence. NVIDIA validates NVFP4 pretraining on 12B Mamba-Transformer. If you want to understand where the open-source AI ecosystem actually stands right now, one of the best places to look is Ollama's model library, a real-time snapshot of what developers around the world are downloading and running locally on their own machines. And the numbers tell a genuinely fascinating story. Meta's Llama 3.1 sits at the top with over 115 million pulls, making it the most widely deployed local language model in this ecosystem by a wide margin. It is available in sizes ranging from 8 billion to 405 billion parameters, covering everything from lightweight laptop deployment to serious server-grade inference. Right behind it is DeepSeek R1 with 87 million pulls, and that number is remarkable given that it was updated roughly 11 months ago. DeepSeek R1 is a reasoning-focused model from a Chinese AI lab that describes its performance as approaching that of OpenAI's O3 and Google's Gemini 2.5 Pro. The fact that it has achieved this level of adoption in what is largely a Western developer community speaks to genuine technical quality, not just marketing. One of the most revealing signals in this data is how prominent embedding models are. Nomic's embed text model sits at 73 million pulls, higher than many well-known chat models. That tells you that the most common local AI architecture is not just chatbots. It is retrieval-augmented generation, where developers connect language models to their own private data using embeddings as the bridge. Then there is OpenAI's GPT-OS entry, which appears at the bottom of the visible list. OpenAI has historically kept its models tightly closed, so any move toward open-weight releases, even selective ones, is a significant strategic shift that could reshape competitive dynamics in the local AI space. The broader takeaway from Ollama's library is that the open-source AI landscape has reached a level of richness and capability that would have seemed impossible just 2 years ago. Multimodal models, reasoning specialists, coding tools, and embedding systems are all freely available for local deployment, and the competition is intense and global. Story 4. Anthropic's push for interpretable AI could redefine how we understand large language models. This article examines Anthropic's interpretability research agenda, which aims to make the internal reasoning processes of large language models transparent and understandable. The work is directly relevant to AI safety and alignment, as understanding how models think is a prerequisite for reliably controlling their behavior. Anthropic's mechanistic interpretability work is considered one of the more technically substantive safety research programs in the field. Story 5, Google AI Edge Eloquent, free on-device dictation app for Mac. Google AI Edge Eloquent is a newly launched free dictation app for Mac that transcribes and refines speech entirely on-device, with no cloud dependency or subscription required. This is a practical application of on-device AI inference, highlighting the maturation of Edge LLM deployment for privacy-sensitive tasks. It competes with cloud-based transcription tools by offering a local-first approach. Story 6. Browse Ollama's library of models. Ollama's model library provides a practical open-source platform for running LLMs locally, including models like TII's Falcon, 7B, 40B, 180B, and code generation models. With over 1.1 million pulls reported, it reflects strong community adoption of local LLM deployment. This is a key resource for developers interested in open-weight model experimentation without cloud infrastructure. Story 7. Meta Llama 3.2 Vision, Multimodal LLMs in 11B and 90B sizes. Meta's Llama 3.2 Vision collection offers multimodal, text plus image input, pretrained and instruction-tuned models at 11B and 90B parameter scales, available on Hugging Face. Updated as recently as April 2025, these models are significant open-weight releases, enabling image reasoning in accessible, locally runnable packages. They represent Meta's continued push to democratize frontier multimodal AI. Story 8. Hybridizing large language models and Markov processes for autonomous penetration testing. This academic paper proposes a hybrid framework combining LLMs with Markov decision processes, MDP-POMDP, and reinforcement learning for autonomous cybersecurity penetration testing. It represents a substantive applied research contribution at the intersection of LLMs, RL, and security automation. The hybrid approach addresses LLM limitations in sequential decision-making by grounding them in formal process models.